Okay? Start with some no's, then we have some yeses, and then we go back to some no's here. So if you look, we only have these couple middle points here from -2 up to 2 there that are solutions. We don't include the 3 and the -3 because when you plug those in, 3 plus 2 is 5. 5 is not less than 5. 5 equals 5. And so it doesn't count. Okay? So, then part B. We switch the inequality sign around and look what happens. Okay? In a way, a lot of places where we had no's now became yeses, and the yeses now kind of became no's. We switched things around. Okay? We switch things around. Okay, so yeah, if you want to take a look there, I'll zoom in a little bit more for you. So it's yes, yes, no, 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 yes, yes. Okay, sounds like a mom. No, 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 no. Okay. So there's that. All right. So what does that have to do with anything, right? Well, the idea is that depending on the inequality that we have, here in this case, it was if we were to solve this, it would be the absolute value of x is less than 3, right? If you subtract 2 from both sides. Here, it's the absolute value of x would be greater than 3, and that's the difference. Okay, it's whether you have the absolute value of something is less than, or if the absolute value of something is greater than. That's going to result in different kinds of solutions. Okay. All right. So, we'll skip the C and the D part there. We'll come back. We'll see kind of what the idea is from here. So, we'll skip down to explain 1 on page 88. Okay, on page 88 there, and we're going to graph. Okay, so Jake, you're just in time. We're just starting to actually solve these things. So, we're on the bottom of page 88 for you there. Okay. Good to see folks are a pain in the butt sometimes. Let's see. Ooh, there we go. Okay, so we can use a graph to solve an absolute value inequality. Okay. We're going to graph each function separately, just like we did before, and then determine the intervals on the x-axis where one graph lies above or below the other. Okay, so for example here, letter A. Let's just look at this one because it's already done for us. Very nice. Okay, if you look here, letter A, they graph the absolute value inequality, or sorry, they graph the absolute value equation right here. So there's the D, right? And then there's 4, right? And I'll look here, we're counting by ones again. So, 1, 2, 3, 4, there's the horizontal line. Okay? Now, we want to know in this case when the absolute value function is greater than 4. Okay? Where is the absolute value function greater than 4? Well, if we look here at our graph, let me zoom in on that some more for us. When the absolute value is above that horizontal line. Exactly right. Okay? So our absolute value function starts to go above that horizontal line right here. Okay? So it starts at -6, but it's for x values that are less than or equal to -6. Okay? So starting at x values, come on, pen, you can write. I know it. There you go. Less than -6. Okay. Where else? Or what other x values will the absolute value be greater than the line there? Greater than 0, right? Because at 0, again, the absolute value function starts to be higher, right, than that horizontal line. And so yes, for x values greater than 0 as well. So we have two solutions. Either x is less than -6 or x is greater than 0. Okay, x is less than -6 or x is greater than 0. All right, let's try another one here. This one's not graphed for us, so we're going to graph it. So we'll first graph, oops, I'm way too zoomed in. Here we go. We're going to graph that absolute value of x. Actually, I'm going to rewrite it above the thing here. That'll make it a little easier to see. There we go. So we want to know when the absolute value of x minus 2 minus 3 is less than 1. So let's graph this. Okay, so Jordan, coming back to you, all right? To graph this, we're going to shift which direction? Right, how much? Ooh, 2, and then what's the minus 3 going to do? Yeah, down how much? Yeah, down 3. There you go. Very good. And again, the way I always remember it, the number that's with the x values go left and right, so the number that's with the x is going to tell you like a left or a right. And then outside, it's the minus 3, so that's going to be your y, up or down kind of thing. That's how I kind of help remember it. So anyway, right 2, down 3. Okay? And then the slope in front there, it's a 1, so we're just going to count up 1, right 1, up 1, right 1, up 1, right 1, and so on and so forth. You get the idea. Okay, and then by symmetry, up 1, left 1 as well. Okay, so there's the absolute value. We also have to graph the horizontal line 1. So that's going to be horizontal line through like so. But now we want to know the x values where our absolute value is less than 1. So at what x value, or past what x value, do we start having our absolute value be less than 1? 6. Okay, so past 6, so you're saying to the right of 6 or to the left of 6? Is this less than 1? Do we want to go left of 6 or right of 6 for this thing to be less than 1? No, 6 is not wrong, but you just got to go in the right direction. If we go to the right of 6, Estefani, the absolute value is going to be higher than the line. But in this case, yeah, we want to go less than 6. Exactly. So we're going to go less than 6, but we can't keep going less, right? Because at some point, our absolute value goes back up over our horizontal line in this case. So what do we have to be greater than? A negative 2. So there's our solution. Okay. The other way you could write this is that x has to be greater than negative 2 and x is less than 6. You can also write it that way. Okay, this way. If you don't like having to write the compound inequality like that, you can just say x has to be both less than 6, like Estefani, identified there, but also it's got to be greater than negative 2, otherwise the absolute value goes back above that horizontal line. So where is it? It's between that negative 2 and the 6, right? That the absolute value function is below our line there. Okay? So I love this. They give you this your turn, and there's no graph. What the heck? Being lazy. So we'll draw one in here for ourselves, and I'm going to have you guys try this one here on your own. Okay? Lazy, lazy, lazy. Try and make sure that your intervals are spread out, evenly and stuff. Your tick marks and things. Hopefully this will be okay. Okay. So go ahead and try number 6 on your own. Okay, give that a shot. Graph the left-hand side, graph the right-hand side, and then try to come up with the inequality that would make this thing true. Okay, try to come up with the inequality that would then indicate the x values where this thing is true. All right. So go ahead, give it a try there. I'll come around and help you if that's necessary. Remember, for that right-hand side, use the shifts to help you figure out where your graph's going to be. Okay, use the shifts to help you know where your graph's going to be. No, anyone that wants to. All right, we just look at it. I'll look at it too. I'll do that as well. Value, and then graph that horizontal line, page 89. So I was looking for an answer. Yeah. Gotcha. Have you taken like drawing and painting or anything like that?
Yeah,
Have they helped to develop your talent, or are you like just doing on your own?
I mean, it has
Yeah. Okay.
I don't know.
Like the shading and stuff like that.
Yeah.
You mean what like that?
Like the way Mr. Big was showing, it's a lot better than just
Right. Gotcha. So you're more of like the comic. You're not. I don't say comics, but I mean like more
like.
like.
Yeah. I know.
Not like realistic, but more like, and I don't want to say cartoony, but again, it's not really.
Yeah, sometimes like I occasionally draw like really realistic people.
Yeah. Where you seeing from? Yeah. Exactly. You said left one, down four. Pretty cool though. I'm saying, I wish I could draw like that. Have you taken classes before?
Yeah, I've taken classes like every year.
Okay.
I took like art 1 freshman year, then I took art 2,
Gotcha.
art 1, then drawing and painting, and right now I'm art 1.
Gotcha. But you prefer the drawing and the painting?
Yeah.
Okay. Gotcha. Let's see. First step, right, is just graphing things accurately, but then coming up with a solution. And again, in this case, with the way that inequality is written, right, you want to see when your absolute value, on the absolute value function, right, the pointing v thing, right, you want to know when that part is less than the horizontal line -2. So, trying to figure out where are the x values, where it starts to be less than -2, and where the x values where maybe it stops to be less than -2. All right, so Carlos, can you help us get this at least graphed? How should we go about graphing this? How does it need to shift? Okay, left 1. And so we'll go down 4. Sorry, so 1, 2, 3, 4. Okay, plot that point there. Yep. Yep, there's a 1 in front there. So yeah, up 1, right 1, up 1, right 1. Hopefully I drew these pretty good. And it was looking all right, I guess. Yep. And then, yep, by symmetry, we got to go the other way too. Oh boy, this is looking kind of sloppy. Here we go. Okay. Okay, so something like this. And then the horizontal line will go through what value? -2. So let's see, 1, 2. So there's -2. So it'll go through here. Ooh, okay, there it is. All right, so we get 2 points of intersection here and here. Oh, Cassie's. What do you need, Cassie? What's up?
I forgot what's my lunch. It's out in the report.
Okay, if you would just go grab it there, it's in your desk still. Okay. Yep, no problem. All right. It's a good thing I wasn't hungry, or else I would have eaten that much. Is there anything good in there? Peanut butter and jelly or something? Oh, okay. Perfect. Great job. Exactly right. Okay, yeah, that's the solution right there. When is the absolute value below that line -2? Well, it starts here at this x value of -3. So let me flip it around this way. X is greater than or equal to -3, like that. But that, yeah, you're right. You weren't wrong. That's the same thing. It's the same thing. But yeah, that's right. Yeah. So we're going to do x is greater than equal to -3, but it also has to be less than or equal to that 1. Okay. But you were right. You were right there. Okay. Or you can write it as one big one if you wanted to. -3 less than or equal to x less than or equal to 1. They do combine together. Is that how you wrote it? Yes. Go for it. Great. Okay. So there it is. Good. 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 All right. So let's take a look then at the next page. Actually, sorry, before we move on, any questions on that? This is a little bit harder than what we did yesterday, right? Because yesterday it's much more obvious. You're just looking for bing, bing, the 2 points where they intersect, right? It's very easy. You got the 2 points, okay? So we know those solutions. But in this case, right, when we're trying to figure out when, this thing is less than or equal to, well, it's equal to at those 2 points, and then it's less than between them, okay? So we want to be between the -3 and the 1 there. Okay. So in this case, the graphing may be a little bit harder than the solving, okay? And so here is the key thing you want to have down for when we solve this algebraically. Here are kind of like the 2 rules. If the absolute value of x is greater than a, where a is a positive number, then x is less than -a, or x is greater than a. What's that? Oh, sorry, we're on page 90. Yeah, page 90 on the next page. Sorry, page 90, top of the next page there. Page 90, I'm sorry. Keeping you guys are like, oh, it's right here, guys. You can't see it? No, I understand. Page 9. If the absolute value of x is greater than a, where a is a positive number, then x is less than -a, or x is greater than a. And the reason behind that, folks, so why is that? Why when you have the absolute value of x is greater than a, why does it turn into these 2? Why does it do that? Well, let me show you. What does it mean to take the absolute value of something again? It is the distance from 0, right? So when I say I want the absolute value of x to be greater than a, that means I want the distance of this thing to be greater than a away from 0. Now, on a number line, if I want to be a units away from 0, that means I'll either be at positive a over here, or where else will I be? Negative a on the exact opposite side. And if I want to go greater than a units away, so here's exactly a units away. If I want to go greater than a units away, that means I want to either be greater than a away from 0, or I want to be less than -a, right? Because this would be the less direction. I want to be less than -a away from 0. And there's where we get these 2 inequalities. See, there they are. X is less than -a, or x must be greater than a away from 0, right? Because to be more than, like the absolute value to be more than a away from 0, you either want to be greater than a away or less than -a away. Compare that to the second one here. If the absolute value of x is less than a, so now, if I again have a number line here, so let's again put a and -a, okay? If I want to be less than a away from 0, that means I want to go from here and go less than. That means I want my x to be less than a. Or here, what would I want? I would want my x to be what? Greater than -a, right? Because I want to be this way. And so what does that result in? That results in this, you can also use it as a compound inequality, like that. Or you can just put, these 2 things with and. Okay. So either the compound one or then 2 separate ones, but with an and. Okay. So that's the meaning behind it. Okay. And so if you care about that, if that'll help you remember it. Like honestly, I think that can really help you learn it real easily. If you don't remember it, here's an easy way to remember it. Okay. Or here's an easy way to do it. If you're doing the absolute value of x is greater than a, then all you have to do is just to drop the absolute value and say x is greater than a, and then flip the inequality sign and make it x is less than -a, in other words. Okay. If it's x is less than a, then you do the compound inequality like that. Okay. So if we look here, for example, at letter A, so many A's, and now look at example A. Okay. You still solve the inequality like you normally would. You subtract the 15 from both sides to isolate the absolute value. Now at this point, if the absolute value of 4 minus x is greater than 6, so which one of these 2? Am I looking at 1 or 2 to help me decide what to do here? Do we have an absolute value of x is greater than a, or do we have an absolute value of x is less than a situation here? Which situation are we which situation applies here? Is it this one where it's the absolute value is greater than a, or is it this one where it's the absolute value is less than a? Which one applies here? The greater than a, it's the first one. It's the first one. And so you'll see, what do? They say, okay, then 4 minus x must be less than negative 6. See, so they make it less than negative 6. So you flip the inequality sign and make it negative 6. Or, there's the or, 4 minus x has to be greater than 6. And there it is, 4 minus x greater than 6. Okay, write that. Okay. So if it's a greater than with the absolute value, it's pretty easy. You just take this and recopy it here without the absolute values. Or you flip the inequality sign around and make it negative. And then again, you solve with just the 4 minus x. And so either way, you get your solutions. You solve each individual thing and you get your solutions. Okay? Here, for less than or equal to negative 2, okay, so here's this one. What should we do for our first step here for letter B? Add 10 to both sides. And so when we add 10 and add 10, we're going to get an 8 here. But now since it's a less than or equal to, okay, we want x plus 4 to be greater than or equal to negative 8. So again, look what happens. Inequality sign flips around, and this goes from a positive 8 to a negative 8. So same kind of deal as we did here. And then we're also going to keep it. So the x plus 4 is less than or equal to 8. Okay? So in both situations, you're going to keep the inequality and the number the same, like we did right here. And then you're also going to flip the inequality sign around and make them the opposite, that negative 8 or negative 6. The only thing that really changes is whether you use the word or and between the two. And so you just finish solving. Subtract 4 from both sides, you get negative 12. Subtract 4 from both sides, you get 4. And then the graph, of course, is going to be different too. Okay? Since the solution is x is greater than or equal to negative 12 and x is less than or equal to 4, in other words, it's the compound inequality, negative 12 less than or equal to x less than or equal to 4. Okay? And so then to graph this, we'll put a dot on the negative 12, a dot on 4, and then we'll shade between. Okay? Shade between. Here for the ors, we ended up going in different directions. And an open circle because it wasn't equal to there. So for the ors, it was different directions, open circle. Okay. Let's do these two your turns on our own here, and then I'll give you guys your assignment. Okay, so we'll just do 2 more examples, and then we'll be done. Okay, we'll do 2 more examples, and then we'll be done. All right, thank you for bearing with me here. Say again, sorry? You got it, okay? Are we ready to move on? Anyone else still need this? We're good? Okay. Remember, folks, that today this is the last bit of new information that you'll need to be ready for the test on Tuesday of next week. Tomorrow what we're learning is material that will not be on the next test. It'll be on the test after that. So we're going to be going into a new unit tomorrow, but it won't be on the test. This is the last bit of new material you'll need to know for tomorrow's test. Or, sorry, Tuesday's test. Sorry. Okay. So let's go about solving this one here. So number 3. All right. Let's go to Patrick. Patrick, for number 9 there, not number 3, number 9, what's the first step we should do here, Patrick? What do you think? Let's start solving this thing. You divide by 2. Yes, exactly right. We got to get that absolute value by itself. Very good. So now we have the absolute value of x minus 7 is greater than or equal to 3. Yep, question. Are you okay with this stuff? Yeah. Okay, then go ahead. All right, at this point, we have to break this up into 2 different inequalities, just like we did with the equations. So we're going to keep it the one way. X minus 7 is greater than or equal to 3. Okay, and then we also will write the x minus 7, but we'll flip the inequality sign and then make it negative 3. Okay, and now the question is, should we put or should we put and here? Which one is it? Or and? So why do you say and? So it's not because it's equal to, it's going to be an or. It's going to be an or in this case. And here's how we can tell. Here's how you can tell. Since it's greater than, we're going to go either more, we're going to go this way or this way, right? We're going to go in opposite directions, so it's got to be or. If it was less than or less than or equal to, we're going to go, we want to stay between 2 things, so we'll say and, because we want to where they overlap. So if we want to go greater than, either we can go greater than, 3 in this direction, or we can go greater than 3 in this direction. So it's or opposite directions. If we want to go less than 3 away, which is a different problem, right? That would be a different problem. Less than 3, we would want to stay between this and between this. Because 3 away, we would say between. Greater than it's or, less than it's and, because it's between. Greater than, away, so it's or, and then less than, and. So like number 10, it'll be an and. So then we finish simplifying here. Patrick, what will we next do here to finish simplifying this? To this. Yep. So x is greater than or equal to 10, or negative 3 plus 7 again, right? So that'll be 4. Yeah, bless you. Okay, so x is greater than or equal to 10. So fill in the dot. And for greater than or equal to, we shade to the right. And for x is less than or equal to 4, fill in dot, right, because it's equal to, and then shade to the left for less than or equal to. Okay? You can also see the or when you go and graph it. When you graph those inequalities, you see they're pointing in different directions, so you can see clearly it's going to be an or, okay, because you're going in opposite directions from each other. Okay? But then we'll look at number 10 here. Okay, so thank you, Patrick. That was good. All right. So at this point, Jake, we don't have any solving to do. Now it's the point to kind of break it up, right? So we're going to have that. Well, so how does it break up again? Do you think you got it, or you want me to help you with that?
Yeah, like so you already have these.
Okay.
Like you already have these. Already along
Yep. Okay. Yep. So we'll do one where it just stays the same, right? 2x plus 3 is less than 5, and then you're right. We'll do the other one where it flips the sign and makes it opposite 5, like that. Is what you were saying? Sorry, there it is. Good. Yeah, that's right. And then what, Jake? What do you do from here? Yep, and so for either of them, you can just subtract 3. Okay, subtract 3. And so we'll be left with 2x is less than 2, and here we'll be left with 2x is greater than, whoops, forgot the x. 2x is greater than negative 8. And then last step. Yes, sir. That's right. X is less than 1. And x is greater than negative 4. Okay. Ms. Whitmire, we just did that warm-up where you told us to flip the inequality sign, right? If we have those negatives. I told you to flip the inequality sign if we divided by a negative. We're dividing by a positive 2 here. Yes, there's a negative 8. But we're dividing by a positive 2, so the inequality sign stays in the same direction. It does not flip. Okay. And so now we'll graph. X is less than 1, so we're going to put an open circle above the 1, and we'll shade left, but don't shade the entire way to the left. Where should we stop shading? At negative 4, because x also, so this is an and, x also has to be greater than negative 4, so negative 4, and we'll shade between them. Okay. So that's an and because we're shading between the 2 points. Okay. And again, it's the less than. The less than becomes an and. Okay. Less than becomes an and. Oh, and I think there's like a little way to help remember this, and it's not perfect, but you know, if you think of the word like greater than, you could think of it as like great or than. Right. And then for less than, you can think less than, to help remember that a greater than is great or than, it's an or, right? And less than is less than, it's an and. The problem with that is that you could just as easily say greater than, so it doesn't really help. But the or is there with the greater at least, and it's not with the less. So that's up to you if that helps or not. But I'm just going to throw that out there. If you don't like it, you can just throw it right back, okay? That's up to you.
You just think of that? Or?
I did not. No, actually, I am. So thank you, Greg, for the compliment that you would think I would be that clever, but I am not that clever. Someone else showed that to me. And I thought it was pretty good, but then I also hated on it because of the whole the and. Both of these could be the and. I was like, well, actually, they both can be banned, and so. But it still might help. I don't know. If it helps you, that's all I care about, really, right? So. Okay, your homework. Let me give that to you here. We're going to have you do on page 93, number 3. Okay, number 5. 3-5. I want you to do 7 through 10. Now, 7 through 10 is matching. 7 through 10 is matching. Yep, so 7, 8, 9, 10. You're just matching the graph with the corresponding absolute value inequality. Then give the solutions as well. So don't forget to do that. Then give the solution of the inequality.
Is that 7, 8, 9, 10?
7, 8, 9, 10. Please. So again, it's going to be 3, 5, 7, 8, 9, 10. And now I'm going to give you 2 more. I know, Mr. Wade, you're the worst. I hate you, Mr. Wade. It's okay. Your hate only makes me stronger. All right, 12 and 13. Okay. 12 and 13. There it is. All right. So I'll put up on the board here too. So, starting on page 93. Page 93. Numbers 3, 5, 7 through 10. And then 12 and 13. All right. So please do get started on this. I will come around and help you, okay, especially because the first couple are those graphing ones, which maybe are more challenging than the non-graphing ones.